2G parameters are the various measurements and settings used to manage and optimize the performance of 2G networks. These parameters are typically set by cellular telecommunication companies and are used to ensure that network coverage and performance meet the required standards. The following are some of the key 2G parameters and how they work. RX level. RX level is a measure of the signal strength received by a mobile device from the network. It is measured in dBm, decibels per milliwatt, and ranges from -110 dBm to -40 dBm. A higher RX level indicates a stronger signal, which translates to better network coverage and quality. To optimize RX level, cellular telecommunication companies can increase the number of cell sites, optimize network coverage, and deploy advanced receiver technologies such as MIMO, multiple input, multiple output, and beamforming. RX quality. RX quality measures the quality of the signal received by a mobile device from the network. It is measured in terms of the bit error rate, BER, which is the percentage of incorrectly received bits. The RX quality ranges from 0 to 7, with 0 indicating the best signal quality and 7 indicating the poorest signal quality. To optimize RX quality, cellular telecommunication companies can deploy advanced receiver technologies and optimize network coverage. C/I carrier to interference is a measure of the ratio between the carrier signal and interference in the network. It is measured in decibels and indicates the level of interference in the network. To optimize CI, cellular telecommunication companies can reduce interference by optimizing antenna orientation, increasing the number of cell sites, and deploying advanced receiver technologies. Handover parameters. Handover parameters are used to manage the process of transferring a mobile device from one cell site to another as the device moves. These parameters include handover margin, handover hysteresis, and time to trigger. To optimize handover parameters, cellular telecommunication companies can adjust the threshold values for these parameters and optimize network coverage. Power control parameters. Power control parameters are used to manage the power levels of mobile devices and base stations to optimize network performance and reduce interference. These parameters include maximum transmitted power, minimum received power, and power control step size. To optimize power control parameters, cellular telecommunication companies can adjust the threshold values for these parameters and deploy advanced power management techniques. In summary, 2G parameters are critical for managing and optimizing the performance of 2G networks. Cellular telecommunication companies can optimize these parameters through various strategies such as optimizing network coverage, deploying advanced receiver and power management technologies, adjusting threshold values, and optimizing antenna orientation. By optimizing these parameters, cellular telecommunication companies can ensure that network performance meets the required standards and provide users with high-quality network coverage and connectivity. Optimizing 2G network parameters is critical for delivering high-quality network coverage and connectivity to users. Here are some strategies for optimizing 2G network parameters. Network coverage optimization. One of the key strategies for optimizing 2G network performance is to optimize network coverage. Cellular telecommunication companies can achieve this by deploying additional cell sites, optimizing antenna orientation, and using advanced receiver technologies such as MIMO and beamforming. By increasing the number of cell sites and optimizing network coverage, the RX level and RX quality of the network can be improved. Power management optimization. Power management optimization is another critical strategy for optimizing 2G network performance. By optimizing power levels, cellular telecommunication companies can improve network performance and reduce interference. Power management optimization includes strategies such as adjusting the threshold values for maximum transmitted power, minimum received power, and power control step size. Additionally, by deploying advanced power management techniques, such as dynamic power control and power ramping, cellular telecommunication companies can further optimize power management and network performance. Handover optimization. Handover optimization is important for ensuring that mobile devices are transferred seamlessly from one cell site to another as the device moves. By optimizing handover parameters such as handover margin, handover hysteresis, and time to trigger, cellular telecommunication companies can improve the handover performance of the network. This can be achieved by adjusting the threshold values for these parameters and deploying advanced handover techniques such as soft handover and make before break handover. Interference management optimization. Interference management optimization is critical for reducing interference in the network, which can impact network performance and quality. Cellular telecommunication companies can achieve this by optimizing antenna orientation, reducing co-channel interference, and deploying advanced receiver technologies such as interference cancellation and equalization. Additionally, by optimizing C/I carrier to interference ratio, cellular telecommunication companies can reduce interference and improve network performance. Capacity optimization. Capacity optimization is essential for ensuring that the network can handle the growing number of users and data traffic. Cellular telecommunication companies can achieve this by deploying additional cell sites, using advanced receiver technologies such as MIMO, and optimizing power management and handover parameters. Additionally, by deploying advanced network optimization techniques such as network slicing and dynamic spectrum allocation, cellular telecommunication companies can further optimize capacity and network performance. In summary, optimizing 2G network parameters requires a combination of strategies that include network coverage optimization, power management optimization, handover optimization, interference management optimization, and capacity optimization. By deploying these strategies, cellular telecommunication companies can improve network performance and deliver high-quality network coverage and connectivity to users.